Learning to ride an Ikon. We call them banshees. It's the test every young hunter has to pass.
So?
But to do that, you gotta go where the banshees are. Hoorah.
Who?
Now what?
Taxi! Y back off!
The movie Avatar, this one, not the Airbender one, is a legendary sci-fi movie that is filled with insane sceneries and graphics. The CGI and animations in the movie feel very real and do not let down. Although the movie contains questionable possibilities such as transferring one's mind into another body, I'll be discussing the physical possibility of the Hallelujah Mountains to actually be able to float. The Hallelujah Mountains in the world of Pandora are filled with superconductive mineral called unobtainium. Superconductivity is the set of physical properties observed in certain materials, wherein electrical resistance vanishes and from which magnetic flux fields are expelled. Materials such as the mineral unobtainium are unable to levitate in magnetic fields because of the Mesmer effect. Basically, the Mesmer effect is the repulsion of a magnetic field from a superconductor. So the question is, how strong of a magnetic field would Pandora need to produce to be able to keep the islands afloat? Assuming the average mountains are cubic shapes and that they have an average height of 1,000 meters and a length of 500 meters, knowing this, we can solve for the mass of these big rocks with the equation mass is equal to rho times area times height, where rho is the density of a rock, which is 2,500 kilograms per meters cubed. Solving for the mass, we get that the mass is 6.25 times 10 to the 11th kilograms. And now that we have the mass, we can solve for the magnetic field using the force on a superconductor by a magnetic field. This equation is P is equal to B squared over 2 mu naught, where P is the pressure of the magnetic field exerted on the rock, B is the magnetic field, and mu naught is the permittivity of free space. Pressure is force divided by area, and the force in this case is the force of gravity acting downward on these rocks. So after doing some extensive research, gravity on Pandora is 20% less than gravity on Earth. And using this knowledge, we can use Newton's second law, F equals ma, where a in this case is the acceleration due to gravity. Knowing that gravity on Pandora is 7.84 meters squared, and that mass is 6.25 times 10 to the 11th, we can conclude that the force acting downward on the rock due to gravity is equal to 4.9 times 10 to the 12th newtons. And now dividing this by the cross-sectional area of the rocks, this gives us a pressure of 1.96 times 10 to the 7th pascals. With this, we can now solve for B in our equation for the force on a superconductor by a magnetic field, and we get B is equal to square root of 2 times the pressure times mu naught. And using the value P is equal to 1.96 times 10 to the 7th pascals and mu is equal to 4 pi times 10 to the negative 7th, we get that the magnetic field produced by Pandora is equal to 24.6 teslas. This value is about 550,000 times greater than Earth's magnetic field. Now, although it isn't probable, it is theoretically possible for there to be a moon or planet that emits a magnetic field that is this big, and that has huge rocks levitating in the air. One flaw in the movie is that the magnetic field this strong would induce currents strong enough to kill a normal human being and prevent the use of aircrafts in the movie. This has been Physics Debunks with Carlos. Peace.